Hello. I wanted to show something about vector animation textures, where basically if you have a lot of animators on the screen, actual animators like this object over here, where it's an animator that then has a skin meshed render. So what this happens is at runtime, the animator will be updating the skin mesh, and that will cost a lot to the CPU because it has to update every single vertex or object in it. In this case, since it's skinned, it's updating everything in it, which costs a lot to the CPU if you have a lot of them. So if you want to reduce how much your CPU is being used, because that's the bottleneck on games, you can actually do vertex animation textures by baking the animation into a texture and then telling a shader to play it, which will look like something like this. For example, for the positions of vertices and the normals. Then the shader will run that and basically create the same exact thing, but fully shader. And I'll show you the difference. So if I turn this off now, right, I go to my prefab over here. I have the original one, the one with the animator and the skin mesh. All good. And at that time, it will play just some idle animation. If I can find actually the run forward, I will put the run forward really quickly. Run. Walk is over here, but I want to run. Oh, there we go. Run forward. Alright, let's set this as the default one. So when it starts, it's gonna do the run animation, just for showcase. And let's set this to spawn. And now, over here, we can see the difference in FPS on your frames. This will spawn 1000 enemies. Oh, they have the roots. Oh, that's fine. They are walking back, but as you can see, they are all playing the animation, but it's playing 30 FPS maybe? 30. Alright. And if we do something like spawn even 2000 more, maybe, like 3000 enemies. Oh yeah, it's basically unplayable, 10 FPS. And this is just with these guys. So imagine when you add more logic to it, when you're shooting bullets or attacking them and you need to do collision checks. Right now they do have a collider, and they have a nav mesh that does the pathfinding. Actually, I should open this. Alright, so the enemy, just to prove that it's not the pathfinding, has a simple script that every 0.1 seconds it will check if the agent has moved. So if the player has moved, in our case the player is this cube over here in the center, and they did not move at all. So what it's going to do is it will only update it once the pathfinding, once they spawn, and then it will update the pathfinding, which will set the destination for the enemy, and that's it. Never update again. So the CPU comes always from the animator, from updating the CPU into the skin mesh CPU and sending to the GPU. So we will change that by changing to the GPU one. So for the example, I'm going to use this test tree, which is the exact same thing, but instead of being one mesh, two meshes, as you can see, this one it has two meshes, which it doesn't need. So you can cut the skin meshes by putting these two together. They had like 10 more, these assets. This is not paid by me, and I put it in two in this case. It has like 11, but still didn't help. So we're gonna turn this off, and we're gonna put our test tree over here on the 000, and as you can see, if I turn the other one, it's the exact same, but it is already animated because of the shader. So let me turn this one off. And now the tests, they're gonna spawn, and as you can see, 150, 200, 107, 190, 170, 180, 180, 200, which is normal behavior for editor, Unity editor, to run around 200 FPS, at least for me, 150, 200, on the editor. Because the editor will cost at least half the frames. Yeah, Gizmos pushes a lot, by the way. And they are all having, in this case, the idle animation, as you can see the tail moving. So they're all playing some animation. What we actually can do is pick one, for example, and we can change to walk. And it's gonna do walk. It's gonna run. You know? So you can do this at runtime, change between them, because the shader holds all that information. But how do we do that? It's very tricky. So there's some bakings that allow you to put maybe one animation, maybe two, maybe up to 8. This one, I made it work up until 16. And I can show you how different they work, because as you notice, my mesh has 2 meshes, so I had that problem and I had to fix it. So what does it do? First version, simple one, I'll show you here, is if you just select one renderer. So when you select your prefab, it will tell you if it has renderers, and you can do separate ones. So if you want to create like a ghost thing, with the, sure, you can do it. Alright. So this will be the first one. So it will create just one. Then the second one, which is the separate ones, where it's one prefab. So it's one prefab with both the 2 shaders. Over here, they're playing at different times, but when I do play, they're gonna reset and they're gonna play together. It's just because it's using time to calculate, and it's not doing it. Did I close the window? I did. Alright, and the second one, which is combined into one mesh. So it will combine everything into one to be as optimized as possible, to have the little objects as possible. But this is preference. Then it will show you how many animations that, in this case, we selected this one. So we're going to check how many animations that animator has. And we can add, like idle, which was what I did. Walk forward, run forward. Oh, I put backwards, that's fine. Attack, for example. And you can also do bake in place, because if you don't do bake in place, what they're going to do is they're going to walk forward. Many animations that have the thing where they just walk off. But you can bake in place, so they stay in place. And then the thing you can do is save the frame steps. Frame steps will be what can save you size on your computer. So right now, as you can see over here, maybe it's too small for the video, but it says the texturings that it will create, normals and position, will cost 167 megabytes. It's because it's taking every single step of every single part of the clips, every single frame, and putting into a texture, which can be nice, yes, but we have something called lerp, where you have 2 different frames, and we can do try to put them together by making like a motion between them, as if there was something in the middle between them. So what we can do is, I can show you the simple one, which is idle. Actually, I can show, I wish, yeah, I need to make this bigger maybe. Alright, idle, we can change this, which means it's gonna skip 1 frame. So instead of having 30 frames, it's gonna have 15. It will skip every second frame. And as you can see, I don't know if you can see it, but it's still the same. Or if I do the walk, it's still the same. Like, there's no difference, right? So what if we do 2? Still the same. And the size went from 167 to 55. 4. Yeah, as you can see, it still works. At the end, gets a little bit freaky, so maybe we'll stay with 3. And it costs 55 megabytes. to have this fully GPU instance. So if you have a game with like 10 enemies, maybe you can do this. So it will cost you like 500 megabytes of your game, but usually games nowadays have like 5 gigabytes or something, or 10. And these will improve a lot the performance if you want to have a lot of the same enemies. And then what you can do, since this is shader, this is fully shader, you can implement your own shader on top of this one. So you can add any, like if it's a single one, you can actually add your own shader to like the effect ones that stay on top. I don't know, I don't have anything over here for the actually. So I doubt I can show something right now. But next video I'll have something to show you, okay? Don't worry. I'm gonna improve because right now alright. So right now I also have something on this, which is when you do a baking of an animation, the animation can bring events. Like if you go over here to an animation, you can have an events over here. In this case, which one can I do? You can add events basically. This is only a read-only, unfortunately. I would need to copy it, but anyways, you can have events, which is trigger something. So if you have an attack and you want to hit damage over here, for example, you can do an event. So what it does is, on this as well, it will check those events and it will create you in it will save those events on the shader as well, and it will play them in the code. So the script that this object has will take care of it. And you can also do something like, oh, play attack animation and then go back to idle animation, for example. You can have that, and I can change something. For example, you can have all that. You can have this also clip blend duration. Clip blend duration is the blending between each clips. So if you're idling and you want to go to walk, it's gonna have some blending where it's to not be snappy. So for example, if I add 1 second to this test 1, now over here on the test 1, we can only do this at runtime. Actually, I forgot to stop the spawns. It was gonna spawn 1000. We don't want that. So on this one example, what we can do over here is change to walk forward, and it will walk forward, start running, attack, oh, idle, back to idle, attack. So as you can see, some animations have slight, if it's idle, it's it's a little bit. This is because of the step and the duration. What you can do is you lower the duration. 1 is a lot, maybe 0.2, and you see which one works better. What you can also do is also on the animation. Yep, there you go, perfect. And it doesn't look snappy. You see it move, and it works. It doesn't snap around. Or you can snap if you want, but yeah, with the idle, with the code, it will do the blending if you want to, as by default. So yeah, that's what I've been working on for GPU instancing, basically the animation fully, and just have a mesh render. This way you can still keep your if you want, have like not box collider but a capsule collider for showing, for like getting hit, for example. So to hide maybe 0.4 radius. Oh, is slightly below center 0, 0, center 1, and there you go. It has the collider 1.8, 0.9, and there you go. You can shoot it, and it still uses the same thing Unity does. So yeah, that's what I wanted to show. Yeah, thank you.